Now let's do an actual measurement on the plant, on the leaf. First I need to turn on the porometer again because I turned it off in the meanwhile. There we go. And well, this is the main, when you start this porometer, this is the main menu. And if you press enter, well it's saved but it doesn't matter. And now it says press enter to begin reading. Now porometer is just resting here. If I would do this now, yeah, this is typical. Right now it says initial conductance is too high, blah blah blah. And this here means that humidity in the device right now is higher than in the outside environment. And this AMB is like the ambient condition. So you see indeed that the humidity is much higher than in the outside air here, and that's because of the previous measurement I did on that wet filter pad, right? So if I wanna, I should open that and then normally it will diffuse, water will diffuse out. But in this way that will go quite slowly. So I just do a bit like this and then it should normally go a bit quicker, more quickly. Yes, you can see now that the black bar there is going down. Yes, okay. And now soon we will do measurements on a plant leaf. And normally in the practical, so you write down the name of the plant and of each leaf. So you would, for example, start with leaf A, which is the brown one here. Well, maybe this one is a bit silly to do because you know it's almost dead, so not a lot would happen there. And then it's actually up to you what you measure. I mean, you should definitely try the upper and the lower sides of the leaves. But then you could say, okay, do I like, do I do measurements on the top, the middle, and below, or only on the where the leaf is almost the broadest? That depends a bit how much time you have and so on. Almost there. So soon what it says there will change. Yes. Now it says place sensor head on leaf, so that's exactly what I'm going to do. So let's measure the lower side of this leaf. And normally, yeah, you should make sure that it's well attached and that no air can escape to the outside environment. But it seems okay because, yeah, I can see. All right, so that's the result. So this means the lower side of leaf A, B, C, D, of leaf E, and about the middle of that leaf, has a conductance of 89 millimoles per square meter per second. And then you would do that for every single leaf of every single plant on both sides. Of course, it could be that maybe you will see a pattern actually I can tell you. The upper side usually has a lower stomatal conductance than the lower side. So mainly the transpiration will occur, in this species at least, in maize, because it depends, but transpiration will mainly occur from this side and less from the upper side. You could think of why that's the case. I mean, and such a question like why, you can answer that from different perspectives, of course. You can answer that rather from a physiological or anatomical perspective, but also from an evolutionary perspective. I mean, one way could be, we could have microscopy actually in the practical. We didn't do that. But of course, you could see under the microscope that maybe on the upper side there is less stomata than on the lower side. And I think, I'm not sure, but I think that's the case. Though it's not necessarily the case. In theory, it could also be that just the stomata on the lower side, they're just opened more than the ones on the upper side. So it's not just the amount, but also how much they're open. And actually, if you would compare among species, it's also the structure and whether they're sunk, for example, sunken, the stomata. Yeah. But now, so if we look further about this question, think further about this question, if we would think from a practical or an evolutionary perspective, imagine such a maize plant or corn plant is in the field. Of course, you will have the main sun rather on the upper side of the leaf. And so that means that the upper side would be a bit warmer than the lower side. So this means that for the same uptake of CO2, more water would go out if it would, on the upper side than on the lower side. So maybe it's more interesting for the plants to mainly use the lower side. The optimum, or we could say the optimum amount or number of stomata could be different. So higher in this case, greater for the lower side than for the upper side, right?